Element 35 on the periodic table is known as bromine. This is Norris Teaches Science with me, Mr. Norris, a physical science edition video. Today we're going to talk about another physics concept known as power. If you haven't watched the video on work, I suggest you go watch that video because you're going to need to know that information to do these types of problems. So the goal is I can calculate power when given data observations. So what is power? Power is the rate of doing work. See that word rate? Do you know, if you've watched my videos, you would know that rate means we're going to mess with time. And to increase power, you increase the amount of work done in a given time. So the power formula. Algebraically, power equals work divided by time, or big P equals big W divided over T. Right? Sometimes it says delta T here, depends on what equation you're looking at, but this is the sense. Power is represented by the big P. Its unit is watts, which we just use a W. The big W represents work, its unit is joules, and the little t is time, seconds. Now, if we take this formula and place it in the triangles I like to use, since W is being divided by T, W at the top, T at the bottom, making P go in the empty spot. All right, so let's look at power. This first question says, if a motorcycle does 2,000 joules of work in 25 seconds, how much power is produced? So we're trying to find power, so we're going to leave P in the problem. At the top goes our work, which is 2,000. Below it will be our time, which is 25 seconds. Now, numbers on top of each other we divide, and numbers next to each other we multiply. Since they're on top of each other, we're going to divide, and we're going to get 80 watts of power. All right, problem number 2. Pause this video real quick. Try to solve it on your own. Did you pause? Why didn't you pause? Pause. All right, let me go over it. Mary produced 20 watts of power in 0.5 seconds doing push-ups. How much work was done? So we have power, we have time, and we have work. We're using the power formula. So we're going to use that formula. We're asked for work. Work goes at the top with a big W. In the bottom left corner goes our power. Power is 20, and our time is 0.5 seconds. Since the numbers are next to each other, we're going to multiply, and we will get 10 joules of work. Is that what you got? All right. Now here's the issue. Since work and power are so related, sometimes you have to do a two-step problem. So if you read the question, it says Beth moves a 15 Newton walker, also known as a zombie, 20 meters in 10 seconds. How much power was produced? There are 3 numbers in this question. 15 newtons, 20 meters, and 10 seconds. 15 newtons is a force, this is a distance, and this is a time. And you're asked to find power. Two things could happen here. Someone could give you these 3 numbers and ask you to find work, and in that case, you just don't have to worry about the time. But if you are asked to find power, you have to do 2 equations, 2 triangles. In the first triangle, you will solve for work. And in the second triangle, you're going to solve for power. All right, so in the first triangle, we're going to solve for work. If you remember, work equals force times distance. Work equals force times distance. So work will go at the top, and we have to take our force. We need to multiply it by our distance. When you get that, you get the work to be 300 joules. All right. In the second triangle, you're going to try to find power. We just did power. the power formula, power equals work divided by time. So we're trying to find power. Power goes here. The top is going to go work. Well, you just found the work over here, so it's going to go over here at the top of the second triangle, 300. At the bottom, you're going to take your time, which is 10 seconds. Now, since the numbers are on top of each other, we divide 300 divided by 10. We get 30 watts, and that is the answer here. And that's a little bit about work, how it's related. That's a little bit about power, how it's related to work, and how it's all related to physics in a sense. In a generalized sense, we're just scratching the surface of physics here in physical science. But I hope you learned something today, and I'm Mr. Norris, and like always, I'm out. See you at the next video.